and find some problems that we need to practice. Anybody at all have a second to do that? Alexis, who's not even taking the exam. Awesome. What is it?
25.
Which one?
25.
25.
It's the area of the rectangular
Remember, guys, if it's marked with a star, it's on the calculator part. If it's not marked with a star, you have to be able to do it by hand. Also, remember, you have one class period to do this. So it will be like a regular test length. There's a white page and a color page. One of them's just front and back, and the other one is front and back, and another one. I can't remember. So it's 5 pages total. I can't remember if it's calculator or no calculator that has extra. But that's all it is. That's the whole thing. None of it's multiple choice. It's all just like a regular test. Work it out and then answer. Well, there's 2 pages front and back, and then the front of another page. Okay? So it's not that much different than a regular test. Because that's how much time you have to do it. All right, here we go. So the first question that we have a question about is number 25. We have a regular octagon inscribed in a circle. The picture's drawn. Everything's great. And you're going to find the area. You've been one of my favorite groups. Don't ruin it on our last day. I know it's Friday afternoon. I know it's 2,000 degrees in this classroom. I know you just want to get the heck out of here, but we got another 45 minutes. We're going to give you your money's worth, all right? Because most of you are going to take an exam. And if you're not taking the exam, if you misbehave this period, you will take the exam. So I need everybody to be engaged and participatory. Here we go. So we know the radius is 10. Our job is to find the area of that thing. Well, does anybody remember how we did that back when we did this? That's back in chapter 5. When we did this, anybody remember? Colin?
So you find the area of each triangle and multiply by 8.
Exactly. So the area, if you do in all these, you'd have 8 of these triangles, right? And they're all the same. So I'm going to find the area of one of them. Now, if I knew this angle right here, life would be good. Because the area of a triangle is 1/2 side times sine of included angle. Abby?
Isn't that like you divide the 180 by 8?
You are right on, but it's not 180. A circle
360.
is 360, right. So this angle, there's 8 of them around here. So this angle is 360 divided by 8. So it's 45. So the area of the triangle is 1/2 10 sine 45. Now I can type that in my calculator. And I get an answer, I get a value for this, but that's not the answer to the question. Remember, this was the triangle. So what do I have to do to get the area of the whole shape? Not divided by 8, multiply by 8. So the answer is 282.84. That would be the answer, and that would be square inches. All right, that's a good question. Good. Abby?
For the final, will we be given like a formula sheet, or we have to know everything?
You have to know most everything. You'll be given all of the formulas for like sums and terms, S sub n and all that stuff. You'll be given any of the trigonometric sum and difference. Remember, like the sine of u plus v and all that. You'll be given those. In here, there's also review over compound interest. You'll be given that formula. There really is that much more. All right, who else has a question? Ben?
We do 2B.
2B. I want to make sure I'm on the right paper. 2B. Does anybody remember simplifying these? This one is easy compared to C, I think. 2B, 2B, 2B. 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 2B, 2B, because everything here is multiplied. Who remembers what we do? We want to simplify this big long mess. What do we do? Sir?
Turn everything into cosine and sine.
Exactly. Now, if it's already a cosine or a sine, I like to put them over 1, but that isn't necessary. Don't change it. Don't change it.
Is it 2B or 1B that we're working on?
Oh, I don't know. I thought it was 1B. Am I supposed to be doing
Oh,
2B?
can we do, well, we can do 1B, but.
All right, I'll finish this one and then I'll do 2B. Sorry, that's my fault. So tangent is sine over cosine. Secant is 1 over cosine, but it's squared because it's squared, and then sine over 1. Okay, so now when I start, looks like the only thing that cancels is the cosines. So multiplying straight across, it looks like I have sine squared over cosine squared, which is tangent squared. Remember, the purpose of a review is to jog your memory. What do I need to study? Is it?
So the like formula where it's like sine over cosine is
Nope,
tangent.
you know that. You know that. That one we know. The tangent of pi. What's pi? 180. So it's not necessary at all, but it might help you if you think about this as the tangent of 180. Where's 180? It's right here, isn't it? And remember that normally when I do trigonometry, I do triangles. Trigonometry means triangle measurement. The problem is when the angle I'm using, 180, is on an axis, I can't make a triangle. I have to make a circle. And I make my circle with a radius of 1, because that's the easiest, which makes this point -1, 0. So x is -1, y is 1, or 0, I mean. And tangent is what? Sir?
Y over x or y over r?
Y over x. Tangent is y over x. Sine is y over r. And with sine, you can kind of figure that out because this is the y side and this is the radius of the circle. And so katoa, sine is opposite over hypotenuse. So that I think you can figure out. This one's a little tougher. You have to remember it's opposite over adjacent. So that would be y over x. So y over x would be 0 over -1, so the answer to that problem is 0. The tangent of 180 is 0. And if you had a calculator, you could type that in and prove that, but we don't have a calculator, so. All right, what else did you find? I'll try to do the right problem. What else did you find as you were looking at this? Yep.
Can you do 4A? Or 4B?
Which one? All right, 4B is a logarithmic equation. Now, when you solve logarithmic equations, the first thing you gotta do is mush these together so you only have one logarithm over here. You cannot solve it if you have two. You have to put it together so it's one logarithm equal to one logarithm. Okay, that's how you gotta start. Now, who remembers, since these two, there's two logarithms here, since they are being subtracted, who remembers how we can put them together as a division? So this becomes the log of x plus 3 over x. When logarithms are subtracted, their numbers are divided. So now we have one logarithm equal to one logarithm. Well, use your common sense. If the logarithm of this is exactly the same as the logarithm of this, what does that mean? What has to be the case?
So the same.
They're the same. So x plus 3 over x has to be 5. Then you solve. So x plus 3 equals 5x. 4x equals 3. Looks like x is 3/4. So what are we doing? We're jogging your memory. You have notes. If you kept your notes, you have notes over all this. You have review sheets over all this. You have office hours on Monday. Maybe Tuesday, I don't know. They haven't figured it out yet. Whether we have a meeting or not. Ollie?
Can we do it for
10. 10 is a calculator problem. And it is a triangle. And we are finding side A. All right. What's your thought?
I forget if it's sine or not, but, there's a bit with the sines of both the angles.
We call it the law of sines. And Abby, how do we know this is a law of sines problem? Because not every problem is. This one is. How do we know? Right there. When you have an angle and its opposite side, you're going to say sine 72 over 10. And what does that equal? Sine 72 over 10 equals sine 58 over A. And then we'll cross multiply. And divide. So we have 10 sine 58 over sine 72. That's pretty easy to type into the calculator, but you haven't done it in a while. Make sure you close the parentheses after the 58. So 10 sine 58 close parentheses divided by sine 72. 8.92 is your answer. Abby?
Can we also do 11?
Yep. Now, 11 does, okay, so there's a difference between these two problems. This one said specifically find the sides. This next one is the ambiguous case. And we just want to know, okay, if we were solving it, how many solutions would we come up with? We don't necessarily have to solve the triangle. We just need to know how many triangles are described by that information. Well, having just done this one, this should pop out at you. That's law of sines, right? So sine 79 over 15 equals sine E over 60. So cross multiply, 15 sine E equals 16 sine 79. Now, this is your variable, boys and girls. So when you divide, you're going to be dividing by 15. So sine E equals 16 sine 79 over 15. Who remembers how to type that in on your calculator? Please, don't just type this. We got a second sign. We got a second sign. So second sign is how you find the angle. This is a decimal. This is the sine value. You need the angle. So second sign, 16 sine 79 close parentheses divided by 15. Is anyone else typing or just me? got error. What does that mean when I got error? There are no triangles possible. This does not describe a triangle. If you had your ruler and your compass and everything, you could not make a triangle that met those measurements. Not possible. Alexis?
Can you then do 12?
12. By the way, what are the possible answers to this question? How many triangles are possible?
0, 1, 2.
0, 1, or 2, that's right. 0, 1, or 2. We got 0. Alright, this looks a lot like the last couple we did, only this time we're finding side C. What's different about it?
It's not a sign.
You don't have the law of signs, kids. See how you don't have that match set? So if the law of signs won't work, I'll have to do the law of cosines. All right, here we go. C squared equals, and by the way, don't come to me and want your pants signed on Monday, because this is how I'll sign them right here. You'll have the law of cosines on your pants. C squared equals 23 squared plus 16 squared minus 2 times 23 times 16 times the cosine of 47. And no, I am not giving you the law of cosines. You need to know, you are a fourth year math student. You need to know law of cosines. This is an easy one to type in. I can just type it in. But who remembers what I have to remember to do after I get it all typed in?
Square it.
I have to square root it. I got 16.82. I did that right. Remember, this is C squared, so when you type all that in, you're going to have to square root it. All right, we've got a lot of trigonometry. Anything else we need to look at? We can do more trigonometry, I don't know. There's a lot here. What do we need to look at?
You do 26.
26. All right, would you agree that 0.2 repeating 7 looks like this if I write it out?
Yes.
And would you agree that this could be divided up and written as a sum of a bunch of other decimals, that if I added up this string, then I would get this?
Yes.
Think about that for a minute. This right here, this much of it, not this, but that much of it is an infinite geometric series, because we are getting from here to here by multiplying by 0.1, 1/10, and multiplying by a 10, and a 10 and a 10. So the sum will be 0.07 over 1 minus 0.1. Remember your formula. This one you will be given, but you have to remember it's infinite geometric. So this is 0.07 over 0.9. I moved the decimal point 2 places. That's the same as 7/90ths, because I don't like to mix my decimals with my fractions. And that is the sum of all this right here. So what do I have to do now so that I get the whole decimal? I got this much of it done. Now I have to add in 2/10. So 7/90ths and 2/10, get a common denominator. 25 over 90, which reduces by 5 18ths. If you took your calculator right now and did 5 divided by 18, it better say this. Because you just figured out that that was the decimal equivalent of this fraction. Or this decimal. That's the fractional equivalent of this decimal. All right, who else?
Number 14.
Now, you aren't going to have to do any graph, you won't have to actually physically graph this, but you will have to figure out y equals -4 sine 2x minus pi over 3 plus 1. You'll have to figure out the amplitude, the period, phase shift, vertical shift, and frequency. Frequency got cut off at the bottom of the page, but frequency is down there too. Okay. You know, you can get all this from just looking there. You don't need to do a bunch of work. Abby?
Does it shift up 1?
It goes up 1, so that's the vertical shift. It'll be up 1, or you can just put +1. It's fine. That's the vertical shift. Right there is where the vertical shift is. All right, what else? Lillian, take a stab at it.
Is the phase shift the pi over 3?
It is, and it's positive. Because when it's x minus, you actually move to the right. Remember that little quirky thing? When it's x plus, you move to the left. So this is right pi over 3. All right, what else do we remember, sir?
Is the period sine 2 or 2?
This has to do with the period, but the period is always going to be 2 pi divided by that number.
Okay.
So 2 pi divided by 2 is pi. That number divides the period. And the normal period is 2 pi, so it's 2 pi divided by 2.
Isn't the frequency 1 over pi?
So the frequency is the reciprocal of the period, so once you figure out what your period is, frequency is just 1 over it. William?
Isn't it -4 for the amplitude?
Actually, it's +4. This is kind of tricky. Amplitude is always positive because it's a height. Amplitude, remember what sine waves look like? Remember? The height of those hills is the amplitude, or the depth of the valley. Always positive. If we were graphing, the fact that it's negative would turn it upside down, but we're not graphing it, so you don't need to worry about that. Amplitude is positive. You're not graphing these on the exam, no. I'm trying to tell you, this is what's on the exam, right? Do this and you will do fine. Donovan?
Number
8. The partial fractions. Okay, who remembers how to do partial fractions? We had a quiz and a test like this. Who remembers how to do partial fractions? Sophia? Yep. We factor the bottom.
And then it would be, A over x minus 3 plus b over x plus 2.
Yep. So, but when you factor your denominator, then you're going to write a fraction for each piece. So you're going to have, and we don't know what the numerators are. So it's called A and numerators. And then one denominator is x minus 3 and the other one's x plus 2. Okay? Then what, sir?
So then you would do A x plus 2 plus B x minus 3 equals
Go ahead.
equals 10x plus 5.
Yeah. So I'm just showing the work for that, which some of you do this in your head and it's fine. Just understand that what you are doing is multiplying by the denominator. So all you have left is ten x plus five on this side. These will cancel and leave you with a times x plus two, just like Sir said. These will cancel and leave you with b times x minus three. Okay, got rid of the fractions. Now what? Alexis?
You got to get the, get the a out to the x plus two and the,
So ax plus 2a will distribute, right? Emma, you paying attention back there? Okay. Now, this is the part that people find tricky, and it really isn't tricky. What do I do now? Izzy?
Don't you take like ax plus bx and then equals 10x?
Exactly. So I don't really, the x's aren't gonna be part of anything, so it's a plus b has to be 10. This term has to add up to these two terms. And then similarly, 2a minus 3b has to add up to 5. Abby? Yeah. So somehow you have to solve this system. So we can substitute, eliminate Cramer's rule, inverse method, whatever you want to do, you're going to solve that system. I'm going to multiply the top equation by 3. So 3a plus 3b equals 30. So 5a equals 35. So I got a is 7. And if a is 7, b has to be 3. Now remember, this is not multiple choice, so you have got to write an answer. This is not your answer. Your answer is the fractions. So 7 over x minus 3 plus 3 over x plus 2. That is the answer. Put your a back over what it was over, and your b back over what it was over, and that's the answer to the question. Ethan, you gonna raise your hand, or you stretching or something like that? All right, who else? And then, you wanna take this exam? Do you have to take this exam? Yeah, all right. Alexis?
9a.
Find the area. All right, who remembers this? Somebody's got to remember how to do this. This is an easy, fun problem. Who remembers how to find the area of this triangle? Come on. Colin?
You add up all three sides.
In other words, we find the perimeter.
Find
So the perimeter would be, that's step 1, find the perimeter. The perimeter is 36. Okay, then what? Cut it in half, because you need the semi-perimeter. And then you use Hero's formula, which is a big radical. And the first number in the radical is the semi-perimeter. You do not use the perimeter. Don't use 36. It's half, 18. Then there are 3 more numbers underneath that radical. There's the 18, which is the semi-perimeter. Then there's 3 more. It is not 10, 11, and 15. 10, 11, and 15 do not go in here. Are you hearing me? This is an easy question, don't miss it. Izzy?
Do you take the semi-perimeter as perimeter and subtract it by each side?
The semi-perimeter minus each side. So 18 minus 15, 18 minus 10, 18 minus 11. Please, what are you doing? Okay, no, you are in high class, this is a class day. Now, you may think this is a terrible waste of your time, but at least pretend, okay? All right, so I multiply these together, 18 times 3 times 8 times 7. Take the square root of all that. I got 54.99 as my area. Please tell me that looks familiar. Those are easy. B, 9B is also easy. We already talked about it when we did the octagon. Area is 1/2 1613 sine 58.
Is what?
1/2 1613 sine 58. Isn't
Maybe 27,
27? Well, 27 is just a couple limits. What's the limit of A? 27, A, limit. 3/5. 27B, limit. 0. Right? Because the power, or the number being raised to the power is less than 1. 5. Now I'm looking at problem 5. This formula you will have, it is the compound interest formula. Here we go. How much will I have in my account if I deposit $1,600 at an interest rate of 3.1%? Please remember, no matter what formula you're doing, when you put a percent into a formula, it must go in as a decimal. So 0.031 divided by 4, because we are compounding quarterly, and we're doing it for 25 years, so it's 4 times 25 or 100. You can type that in exactly the way I wrote it, and it'll be okay. Make sure you're getting for $3,462.59. Okay? Gabe,
Which ball is this?
that was number 5. Alexis,
can you do 22?
22. All right, now, for this, you've got to think about what your strategy is going to be. So it's a probability question, so we could draw a Venn diagram, we could make a tree, we could do combinations, there are lots of things we could do. Read the problem and see if you can think about the best way to set this up. What do you think? I would do a tree. I would do a tree. Now, here's why I would do a tree. Because there are 2 sets of probabilities in the problem. There's a probability that I'm in uniform, and then there's a probability I'm late. So I'm going to have one level of the tree be uniform and one level of the tree be late. But I got to figure out which one is which. Anybody remember?
Uniform will be on the bottom. And
Uniform will be on the bottom. So I'm in uniform or I'm not in uniform. Right? Because that's the question that's asked. God bless you, sweet pea. I will see you more. All right. And then and then the other one is being late or not late. Okay, here we go. Do we know some numbers now? If a student is late, the probability he's in uniform is 0.38, which makes this one 0.62, because these have to add up to 1. If a student is not late, uniform is 68, so not uniform is 32. 24% are late. So how do those numbers look to everybody? Does that seem reasonable? Looks great, thank you, Ethan. Now, I want to know what's the probability I'll be in uniform. Abby?
I think we start with the 0.24 times 0.38.
That's exactly what you do, so let me write that down. This is the probability that I will be late and in uniform. So you multiply, late and in uniform. Okay, then what?
Then it's 0.09 and then it's 9%.
Oh, so you figured out what that is?
Yeah.
So it's 0.09? Is that what you said? Okay. It is? Did you round that off?
Is it not?
Let's not round
It
it
was
off.
0.0912.
All right, let's keep all those decimal places. Okay, there you go, good. Okay, then what, Abby?
And then it's 9%.
Okay. Oh, wait, we're not done. Because the question is, what's the probability I'm in uniform? And can't I be in uniform 2 different ways? I can be late and in uniform, or I can be not late and in uniform. So I'm going to do the same kind of arithmetic on that piece of it. So the total probability would be that plus this, because this is an or, so I'm going to add. And I got 0.608 as my total probability of being in uniform. A tree diagram is valuable because we can be in uniform 2 different ways, late or not late in uniform. Lillian?
Would you change it to a percentage like 60.8?
You can, 60.8, that's completely up to you, I don't care. Alright. Sir,
Yes.
what are you doing? Just turn around. Donovan? 16. Alright, there are 32 students in the math class, 17 of them love everything, 20 love this, 22 love this. Okay. On the test yesterday, you might recall that I was very nice because I said, use a Venn diagram to do this problem, or use a tree diagram. I'm not doing that on the exam. All right? So you figured out this was a tree, and that was good. That was right. I mean, that's the easiest way. Not the only way, but the easiest. What about this problem, number 16? How do you think that one would be best approached? Yeah, that's a Venn diagram. It just feels like a Venn diagram because you've got these people that like polynomials or logarithms or both. I'm going to change these so it matches the order of the question. Living logarithms and polynomials. There are 32 of them in the box. So the box holds 32 people. All right? 17 of them love both polynomials and logarithms. So does the placement of that 17 make sense to you? 20 love logs. Now, this is wrong, but this is what I saw on your test. What is wrong with that, Izzy?
So the 17 like both.
20 is the whole L ball. These are the people who like logarithms, and there's 20 of them. But you already counted 17 of them, so this isn't a 20, this is a 3, so the whole ball is 20. And similarly, the whole p-ball is 22, so this is 75. Now, how many people are in the balls? 25? But wait, there are 32 kids in the class. So what does that mean? There's 7 of them out here that don't like either one.
More belongs that messed up.
Now, so you're right here, you're 1 and 3. On the test that you just got back and turned back to me, you had a question just like this, but it was, what's the probability that if I reach in and grab a kid, he won't like either one? Well, if there's 32 kids all together, won't that probability just be 7 over 32? Yeah, the number of kids is 7. The probability would be 7 over 32. All right, let's do 2 more. And then you will never have to listen to me again unless you're a junior. Izzy?
Number 18, please.
18. Find the 4th term of this expansion.
Now you wish you could say
All right. Now I want you to think about when we expanded these things, when we wrote them all the way out, the big long things. Every single term has a coefficient, a number, an x, and a 4y. So the first thing I'm going to do is figure out what that number is. Sir?
Would it be, 8C4?
Well, it's 8C something, and it might be 4, but I'm going to count it just to make sure. So the first term is 8C8, 7, 6, 5. So the 4th one will actually be 8C5, and I did that magically by counting. So 8C5, that you know what that is. That's 56. So my number is 56. Next to the 56 is going to be an X and a 4Y. Sir?
It'll be X to the 5th, 4Y to the 3rd.
Okay. Remember, they got to add up to 8. Now, how did he know that was 5? Well, that number comes from counting down exactly the same way we counted down to get this. Right? The exponents, 8, 7, 6, 5. So this is going to be 56 x to the 5th times 64y cubed. That has to be multiplied. Some of you left them separate. They need to be multiplied. So 3584 x to the 5th y cubed is the term.
Can you explain again why the 5 came from, like the C?
First term is 8C8, 8C7, 8C6, 8C5. The 4th term is the one I'm looking for, and it's 8C5. All right, one more. One more problem. Always.
Number 6.
6. How many radians is 500 degrees? Does anybody remember a little bit ago we had a problem that was the tangent of pi, and we said we're going to think of that as the tangent of 180. So 180 degrees is pi radians. We want to know 500 degrees is how many radians. Anybody remember how we do that? We set up Abby? Almost, be careful. I'm going to say pi over 180, and then it's going to be x over 500. It doesn't really matter, Abby, but you got to make sure that wherever you put the 180 in the fraction is the same place you put the 500, because these are the degrees. Okay? So if you had 180 over pi, you had to have 500 over x. Okay? All right, so 180x equals 500 pi, divide. These almost always simplify a lot. 25 over 9, 25 pi over 9, I think is the radian measure of 500 degrees. Now, boys and girls, those of you taking the exam,